In this episode, we're going to look at an example on network representation. I'll show you how to do it and have a discussion of the concepts along the way. We'll be discussing the network model in this activity that incorporates many of the technologies that you'll master in your CCNA studies. It represents a simplified version of how a small to medium-sized business network might look. Feel free to explore the network on your own. Greetings to all my tech heads out there in the KevTechify Nation, and if you're new here, welcome. This episode is part of my series on practical configuration examples for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. Okay, I've loaded in the packet tracer assignment 1.5.7 network representation. On the left side, I have the sort of your work area where the network is, and you can go in and you can configure those devices. Then on the right side, I have the Word document up there. I'm using the Word document here so I can go in and put my answers in there, fill in the blanks as I go through and complete this. Now, when a packet tracer starts, first part normally is the objectives, why you're doing this. Here, we're getting familiar with packet tracer, and we're also seeing how the different components of a network are represented inside of packet tracer. Now, how we represent them inside of packet tracer is commonly how industry represents them with the drawings and the diagrams and stuff like that. After the objectives, we have the instructions. The instructions here are typically broken into major parts. Each major part is called a step. For this exercise, we have 3 steps. Step 1, identify common components of a network as represented in packet tracer. So in the bottom left down here, that's what they're talking about. This area right in here, this is where we're seeing the connections, the end devices, custom-made devices, multi-user connections. List the intermediary devices categories. So right now, I am looking at this area here. It says list the intermediary category devices. Now, once again, remember, what is an intermediary device? That's a device on the network that passes data through it. Data doesn't start or stop there. It's a router, it's a switch, that type of stuff. Now, looking over here on our diagram, let's look up here in the home office area. In the home office area, we have listed a couple items. We have the wireless access point, wireless router. We have the modem. Data passes through there. Notice that the rest of these here are end devices. That's where data starts or stops. That's where an end user goes in, types in their command. They send a print job. It goes through the wireless router, and then it goes to our inkjet. Data starts and stops at our end devices. Intermediary devices passes it. So our intermediary devices here, starting up here, is we have a wireless router and we have a modem. So in my document, I'm going to come over here. I'm going to say a wireless router modem. Down in the bottom left here, notice there's some things that are passing data through here. We have servers, we have PCs on the ends here. So these are end devices, but everything else here is an intermediary device. We have LAN switches, so that's another item we can add in here. LAN switch. We have our routers. This is a router. Routes between networks, and you've noticed we connect up different networks to it. Down here is one network, down here is another network. This red lightning bolt representing a WAN connection is the third network. Second red lightning bolt represents a fourth one. So we have routers we can add to our list. Router. This symbol here is for a layer 3 switch. This device does the job of these 2 components of your LAN switch and your router. This does routing and switching. For us, this is outside the scope of our course, but I just want you to know what it is. If you're continuing on going for your CCNP, you're going to deal with these layer 3 switches. Then over here, right, we look at the right side here, we notice once again all of these devices on the end here that the wire comes into, and it stops here, data stops here. This here, these are all end devices, but in here we have some intermediary devices. We have our router here again, we have a LAN switch, and we have a wireless access point. So we have that in here. Now we'll put wireless access point here. And we're looking there. As we look at our list, there's one more thing here. This modem's also called a WAN emulation device because it allows us to make that connection in there. It changes from our network to somebody else's network at that point in time. That could be, like I said, a WAN emulation device. Okay, so that takes care of all the intermediary devices. Without entering the internet cloud or internet cloud, now what we're talking about here is this thing right here, this cloud. For the internet, this is the intranet. Now, the idea of a cloud is we're not concerned right now about what happens inside that cloud. We're concerned about the outside of it. We're concerned about our central office down here. We're concerned about our home office up here. When we connect into these clouds here, we don't necessarily are concerned for our conversation what's happening in there. And in this course, we don't deal with a lot of WAN technologies. We deal a lot with the LAN, the local area networks. The WAN technology, that's when you're getting into your CCNP stuff. So here what we're concerned with is we can connect in on one side, we connect in on the other side, and our data makes it through there. It's sort of like you jump in your car and you start it. Are you concerned about the engine and cylinder size and the compression and the fuel injection and all that? No, most of us aren't. Some people are. I got a mechanic friend who is really into that. But for me, I'm concerned that I jump in, put my key in there, I start my car, and it works. Same thing with the cloud. You connect it on one side, you connect it on the other side, and it works. Take your home for example. You connect your $50 Linksys Belkin D-Link router into your modem from your ISP. You're concerned it works. You don't necessarily concerned about all the other stuff that's happening behind the scenes. And so that's what the idea of the cloud is. So without entering the internet or intranet cloud, how many icons in the topology represent endpoint devices? Only one connection leading to them. Well, how many devices do we actually have? Well, in our home network, so there's only one connection coming in. So data comes in there and it ends. At this point in time in our home network, we have 1, 2, 3, 4 end devices. In the central office, we have 1, 2, 3, 4, 5 down there. In our branch office, we have 1, 2, 3, 4, 5, 6. So we have 4 plus 5 gives us 9 plus 6 is 15. We have 15 end devices at this point. I hope you're liking this episode on practical configuration examples. Leave a comment on what you think about these configuration examples. If you still have a question or comment, please let me know below. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. Moving on to the next question. Without counting the two clouds, how many icons in the topology represent intermediary devices? Multiple connections leading to them. So once again, data traveling through here. Over here in our home office, we have 1, we have 2. In our central office, we have 1, 2, 3, 4, 5, and 6. 1 and 6. Down here in our branch office, we have 1, 2, 3, 4. So 1 plus 6 is 7, plus 4, that gives us 11. So we have 11 intermediary devices. How many end devices are not desktop computers? Now looking at this, how many end devices are not desktop computers? So once again, an end device is where the data ends, where the journey starts, or where it comes to completion. So how many are not desktop computers? In the home office, we got 1, 2, 3. Central office, we've got 4. And in the branch office, we have 5, 6, 7, 8. We have 8 total end devices that aren't desktop computers. Next question, how many different types of media connections are used in this network topology? Now, once again, the network connections, the media connections, are how do we connect things up? As we start looking here at our home office, we have this black straight line. The black straight line, once again, represents a local area network. Now here, this is sort of a new symbol for us. Inside of Packet Tracer, these are sort of dashed lines that are stacked up on top of each other that make a line. And what this represents is our wireless medium, air. So we have a LAN connection here, we have a wireless connection here. Looking at all of our other locations, central office, we have all LAN locations in there. Our branch office, we have all LAN locations in here. Now, when we look here in the center, we have the red lightning bolts. Those are our WAN connections. And then here, coming up to our home office, this is basically it's a leased line. So it's a little bit different than a WAN connection. So that gives us our 4th connection. So we have 4 different types of media. On to step 2, in Packet Tracer, only the server-PT device can act as a server. Desktop and laptops, PCs cannot act as a server. Based on your studies so far, explain the client-side model. The client-server model. Sorry about that. Explain that client-side model. Okay, step 2. Explain the purpose of devices. So in this part, we're going to talk about what are the purposes of these devices. Step 2A. In Packet Tracer, only the server-PT device can act like a server. Desktop and laptop PCs cannot act as a server. Based on your studies so far, explain the client model. The client-server model. Well, the client-server model, that represents there's a client. A lot of times you can think of it as your laptop, a tablet, your phone, and then you're going to access data on a shared device, and that would be your server. That's where you go. That's where 1,000 people go to get a web page downloaded. That's where the files for all of your orders are kept, and you can process that. So it's a relationship between end devices. One is asking for information, the other is serving up that information that was requested. And so that is our client-server relationship there. List at least 2 functions of intermediary devices. So 2 functions of intermediary devices. On to step 2B. List at least 2 functions of intermediary devices. Now, once again, intermediary devices pass data through that. They do several things for us. First one that they do is they regenerate signals and retransmit it. So when they get a signal in, they regenerate that signal. They get it in, they clean it up. Think about somebody yelling at you across the football field. You can kind of hear them, right? And you can kind of make out their message. But if somebody stood in the middle of you, heard the message, and then re-yelled it again, it would be much clearer. And that's what one of these intermediary devices can do. They can also maintain information about which pathway is the best way through the network. If we look at our diagram here, to get from the central office to the home office, there's actually 2 paths. One is a direct connection from R2 to the internet. The other one goes from R2 across the internet to R4, then it goes out to the internet, and then up to the home office. So there's 2 paths through there. So it maintains multiple paths. Another function it does is it notifies other devices of communication failures. So it notifies of communication failure. So if for some reason one of the devices isn't working, it'll let the other ones around it know. It will direct data on to which paths are the best. So it's going to direct data. Once again, which path is the best to go from our central office to our home office that we see here? Does it go from the central office to the home office? Maybe this connection here is down for some reason. A backhoe cut through the ground and cut the fiber optics, so it can't go there. So this router is going to direct the data to go all the way over to our branch office with R4 and then up to our home office. And so that way we can still get our work done at that point in time. We can start using quality of service on our network. Once again, quality of service is giving we can use quality of service, QoS, on our network. That is giving priority to certain types of traffic on our network. Typically, we give real-time traffic, voice and video, priority over our other traffic on our network. And then what intermediary devices can also do is they can control data flow. Meaning they can stop certain types of traffic from coming on our network. They can deny certain traffic based upon where it's from or where it's going. So the intermediary devices can do quite a few. Okay, we're going to move on to step 2C here. We're going to list at least 2 criteria for choosing network media type. Now, the criteria, it can be a lot of reasons. The ultimate reason is what works best for your network, what works best for your company. Now, some of the things we can look at here, well, distance is one of them. How far do I need to transfer that data? Is it just across the room? Is it across the building, across the street, around the world? That will determine what media you're going to use. What speed do you have to send it? Is it a lot of data we're trying to send really quickly? Then you really need a high-speed connection. But if it's just the Word document that needs to make it across there, you don't need as fast of a network to get it across there. Also, the other thing you need to look at is the cost of the media. Some media cost more than others. Some cables cost 20 cents a foot. Some cables cost upwards of $50 a foot. That's a big price difference there, and you have to know which one you're looking at. Okay, we're moving on to step 3 here. Step 3, we're going to compare and contrast LANs and WANs. Explain the difference between a LAN and a WAN, giving an example. So, for our LAN here, typically it's a smaller geographical region. Smaller area. Now, what do I mean by that is it's a lot of times it's a room, it's a floor in a building. It could even be a building. But that is typically one local area network. Where a WAN, on the other side, is a larger area. Now, that larger area could be something like, if your LAN was just a room, that WAN could be the building. Or it's the connection between buildings that go across the street. So size is a big thing on it. Also, for LANs and WANs, it's who controls it, who owns it. Now, for a LAN, typically you own it. You buy the switch, you buy the cable, you pay the monthly electricity bill. You own it, you control it. You have the passwords to get in and change that. That is typically describes LAN equipment. WAN, on the other part, is normally you go into a service provider. You have to have a contract with a public utility, because a lot of times you cross public right-of-ways and that only public utilities can do that. And you typically have a monthly bill. Every month you have to pay so much. It's like your cell phone or your internet at home. You have a monthly bill where you have to pay for that. You don't own that network. You have a contract that lets you use some of that network. So what we typically say here is you have a service provider. On step 3B, in packet tracer network, how many WANs do you see? So inside of this network, inside of our network over here, how many WANs, wide area networks, do you see? Well, in this diagram here, we have actually two WAN. One here is the internet, and the second one is the internet. First one is the intranet, second one is the internet. So what we have here is we got two networks. We have two WANs, intranet and internet for us. How many LANs do we see? How many local area networks do we see? Well, inside of Packet Tracer, for this example here, we have 3 of them. Now, how can we identify that? Well, if we look here, this is all typically equipment you own. Now, you might not own your modem. It depends upon what your contract says for your connecting into your ISP, but you typically own all of this. And inside of Packet Tracer here, we drew a box around it. Down here on our central office, this here is one local area network, everything up to it. Now, who owns this router right here is up between you and your internet service provider. But basically, you have control of these ports right here. Your ISP would have control of those outer ports connected on the WAN connection. And so we have one network down here on our central network. The branch network, same thing. This is all one local area network. So we have 3 local area networks. We have central, we have branch, and we have home office. On to step 3D. The internet in this Packet Tracer network is overlay is simplified and does not represent the structure and form of the real internet. Briefly describe the real internet. Now, if we remember our discussion from episode 1, the real internet is a very complex, extremely large collection of WANs and LANs, getting all that working together. So it's LANs and WANs, and I'm going to say it's lots of LANs and WANs working together for you. On to 3E. What are some of the common ways home users connect to the internet? So when you're at home, when you're in your apartment, what are some of the common ways that you can connect into it? Well, DSL is a way. Hopefully you don't have to go through DSL. Hopefully you live in an area that has a different alternative. One is maybe your cable provider. Your cable provider can give you speeds up to 100 or 200 megs per line. You can also have, you can also have cellular, which the new 5G coming out, that may be a good solution for some of you. We also have satellite. If you live in rural area part of the country, there's not a lot of people around you, there's not a lot of big towns, and cable providers don't want to go out there. Satellite may be a way for you to get it, and so we're looking at satellite. And down to 3F. What are some common methods that businesses use to connect to the internet? Well, once again, we have our dedicated leased lines, and that would be T1s, T3s, E1s, E3s. how we get that information in there. We have what we call Metro Ethernet. That's a new type of Ethernet out there that gives you some high speeds across long distances. They can use a business DSL. Once again, it's a little bit better than what you would pay at a residential level. You do have business cable. And for a lot of small businesses, that works great. And of course, we do have satellite. The satellite there gives us our... It was my pleasure to provide you with this wonderful episode on configuration examples. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. Thank you so much for watching this episode of my series on practical configuration examples for the CCNA. I've created 4 wonderful playlists for you on the CCNA. These episodes, I go through all the concepts that Cisco calls out for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.